Hello, Dr. Knudsen here, and I'm going to show you how I would do a permutation test with a really simple example in R.
In the previous video, we looked at an example where we had textbook prices for biology majors and then for sociology majors, and we were interested in comparing the two groups to see if the two means were different from each other. So we gathered some fake data. So here's biology. We had 4 students and they paid $320, $480, $290, and $350. Then for the 3 sociology students, we have $180, $260, and $220. So to start off, I just typed that into my script here, and we can run that. So I ran these 2 lines, and if we want, we could take a look at them. So there's bio, there's sociology, and we can look at the mean of sociology and the mean of bio. So the mean textbook price for the bio group was $360. The mean textbook price for the sociology group was $220. Okay, so one of the things that we need, as we saw in the previous video, is to save those, the difference in those two means. So we'll call that our OG test stat, and that's just the mean of the bio group minus the mean of the sociology group. Okay, and if we want to take a look at that, oops, then it would be 140. And then one trick that I like to do is just surround the command here. So we can see that when we just have this line here, it calculates the test stat, but it doesn't spit it back out. So if we want to calculate it and spit it back out all in one go, we can surround that line with parentheses like that, so it calculates it and spits it out. So that's a good way to like kind of check your work as you're going, because you don't want to like code a bunch of stuff blindly, not knowing what's going on. So here we can see like, okay, this makes sense that the difference is 140 because we know 360 minus 220 is 140. All right, so that's our test stat from our original data. And remember that our hypotheses are, oops, our null hypothesis is that the two means are equal. And our alternative hypothesis is that the bio majors pay more than the sociology majors on average. So let's go ahead and write that down. Null hypothesis, the two means are equal. Mu bio is equal to mu sociology, or we could write it as mu bio minus mu sociology equals 0. And then our alternative hypothesis is mu bio is greater than mu sociology, or we could write down mu bio minus mu sociology is greater than 0. So I like to write the alternative hypothesis and null hypothesis down in this second way here, because that'll set us up for our test statistic. So our test statistic will be something relating to estimating mu bio minus mu sociology. And in this case, we're going to estimate mu bio with just X bar bio, or in other words, a sample mean for the bio group. And then mu sociology will be estimated with X bar sociology, or in other words, the mean of the 3 sociology data points right here. Okay, so this is our test stat, mu bio, mu bio's estimate minus mu sociology's estimate, or in other words, X bar bio minus X bar sociology. So that is our test statistic. Now, we know that we need something to compare this to so that we can know if 140 is just happening by random chance, or if we're getting a difference that big because biology students really do pay more than sociology students for textbooks on average. Okay, so we know that the basic idea of what our test setup will look like is we're going to repeat a process many times, and it will be this process here. We're going to pool all the data together, and then we're going to randomly split the data into 2 groups. One group will have 4, and we'll call this bio. and then the other group will have 3. So we're just going to randomly split these data points up. And remember, the basic idea here is if there's truly no difference between how much bio students and how much sociology students pay on average for textbooks over the course of the semester, then this 180 could have just as easily come from a bio student as from a sociology student. And similarly, this $480 could have just as easily come from a sociology student as it did from the biology student. So pool the data and then continuously or repeatedly resample the data. So repeatedly randomly split the data into 2 groups. One group has 4, the other group has 3. And we're going to then calculate the means for each group and then find the difference. Then we're going to store those differences in means, and that will build our null distribution. So that null distribution is what we're going to compare our original test stat to. And if our original test stat looks pretty extreme compared to the null distribution, then intuitively we can say that biology students pay more than sociology students. Okay, and so like that's the intuition, and then to actually get our test, our p-value, but we'll need to count how many test statistics from the null distribution are more extreme than our original test statistic. Thus, this is the basic idea of what we're going to do next. So we are going to need somewhere to store all of these simulated differences in means. So let's create a vector here that will allow us to store those simulated differences in means. Okay, so maybe I'll just call it null dist since it's going to be our null distribution. And let's just fill that with some value that is like very unlikely for us to see, so that we can know later if we see this value, like maybe something weird is happening. So let's just fill it with like -999, and we're going to have m be the number of times we resample. And we want to choose a big number, so for now let's just choose 10 to the 4 because we want it to be big, but we don't want it to be so big that it overwhelms our computer. So here we go with m equals 10 to the 4. And we're going to use this rep. And let me just demo what it looks like if we have rep -9993. What this rep command does is it makes a vector of length 3, and the entries are all -999. So if instead I made it with -999 rep 10, it would repeat -999 10 times. And we want to have it be of length m, which is 10 to the 4. So we go ahead and run that. And then if we wanted to like kind of check things out, we could say length null dist, just to see how long it is, to make sure things didn't get wonky in there. And then we could do head null dist to see the first few entries, tail null dist to see the last, whoops, spelled that wrong, tail null dist to see the last few entries in there. Okay, so we can see that we have this vector of length 10 to the 4 filled with -999, and later we're going to put in our simulated differences in means into this. All right, now let's start with our, start setting up our loop, but actually let's do one thing before that. Let's pool all the data together. So null dist, where we will store our differences in means. And these are the simulated differences in means. Pool data, this is going to be our entire set of data, so all 7 numbers. Okay, so we can take the bio line from up here and the sociology data from there and just use C to smush it all into one vector. So C, bio, socio. And again, let's use our trick of having the 2 parentheses to check out that data. So there we go. We can see that we put it all into one vector and there is our data right there. Okay, so now we've done some of that setup. We've chosen the number of resamples. We have set up a place to store our simulated differences and means. We've taken all our data, smushed it into one vector. Now we can go ahead and set up our loop. So we need to set up a loop because we will be doing this process repeatedly, and so we don't want to like code it over and over and over. Many ways to run loops. Usually the one that I just like default to is a for loop. So for I in 1 through m, that's how we write for loops in R. And then we use curly brackets, open and close. Okay, so let's think about what we want to do here. We want to randomly split our data into 2 groups. And then we want to calculate the mean for each group and store the difference in means bio minus sociology. Okay, so let's think more about this like random splitting thing. We have 7 numbers. So what we can do is use the sample command, and let me demo that for you one time. So if we do sample 1 through 7, this will randomly sample the numbers 1 through 7. And if we look at the help function for this, $sample, we can see more information on it in order to make it do more of what we want it to do. So here's this size argument, and replace equals true or false. So size, let's see what happens when we do sample 1 through 7, size equals 3. We can see that when we don't say size equals something, then it will default to resampling all the data. So in other words, this is just like rearranging the numbers 1 through 7. Here, when we say size equals 3, then it's going to randomly select 3 numbers out of 1 through 7. And it will then tell us those 3 numbers. So let's just do one more example to see how that works. So sample 1 through 7, size equals 5. We can see it's randomly selecting 5 numbers without replacement from the numbers 1 through 7. Okay, so we want to split our data into 2 groups. One group has 4, other has 3. So what we can do is sample 1 through 7 and take size equals 4. And we can see I stored it as these, and these are 3162. So if we take these 3162, so if we're taking the 3rd entry, the 1st entry, the 6th entry, and the 2nd entry from pooled data, whoops, then we're grabbing out the numbers 290, 320, 260, and 480. So let's look at our whole data set again. to see what's going on there. Okay, so the first number in the vector these is 3. So if we look at the third entry in pooled dat, we see the number 290. So when we're using the square brackets, that does indexing as we saw before. So pooled dat 3 goes in and grabs the third number. Pooled dat 1 goes in and grabs the first number. Pooled dat 6 goes in and grabs the sixth number. Pooled dat 2 goes in and grabs the second number. So by saying pooled dat these, because these is 3162, pooled dat these is going to go in and grab the third, the first, the sixth, and then the second number from here. So that is how you can go in and grab the fake bio group. So we're going to go in, grab those 4 data points, and call them bio. Okay, and then let's take a look at fake bio just to make sure it's what we think we're creating. And so we can see, yes, it's going in, grabbing the numbers that we want. Now we need to have the remaining numbers be the sociology group. So we again use the pooled dat, and instead of saying go in and grab these, we say go in and grab everything except for these. And when we use our negative sign within the indexing square brackets, then that means everything except. So let me do an example here. So remember pooled dat looks like this. If we go in and grab everything except for the first data point, then we get everything except the first data point, I guess. And the way that we would write that is -1. And if we wanted to go in and grab everything except the sixth data point, we would say pooled dat -6. So when we say pooled dat negative these, then that means from the pooled data, go in and grab all the entries except for these entries. So that ends up pulling out 350, 180, and 220. So now we have our data split into 2 groups. We have our fake bio group, we have our fake sociology group. Now we can go ahead and calculate the mean for each group. So the mean for the fake bio group is 337.5. The mean for the fake sociology group is 250. And then we'd want to go and store the difference in means. So here, actually, I probably wouldn't even make this a separate line. We do want to calculate those, and I would, like, as I'm coding it, like you can see, I just like did a little bit there. But once I'm actually going to have a loop that I run, then I would do mean of fake bio minus mean of fake sociology, so $87.50. And then we want to store that in our null distribution in the ith entry. And what is I? What's this I here? It's just our indexing variable. So we said for I in 1 through m, so for the when I equals 1, then it will go run this first bit, calculate this difference, and put it into null dist 1, meaning the first entry of null dist. So let's just like do this one time just to make sure that the innards of this loop are working. So we have these. Let's just take a peek at what these are in this situation, 1573. It goes in. Next, we grab those entries from pooled dat and store it as fake bio. Similarly, go and grab the everything except for these and store it as fake sociology. And then we can go ahead and take our difference in means and store it in the first entry of null dist. So now if we looked at head of null dist, we still have a bunch of -999s, but we also have our very first difference in means that we have simulated. So there we go. That's what the loop is doing one time when we go through it. Now that we're like satisfied that it will probably work, we can go ahead and run the whole loop. So this is an important thing. Like when you're writing a loop, you don't want to just like write it and then like try to run it, because you're probably going to make a mistake. Like that's just how coding works. You make mistakes and then you fix them. So go in and you debug it by like running through the innards of the loop line by line. So that's what we just did. We ran it line by line. We checked like what was fake bio, what was fake source, so that we could like make sure that things were going as planned. If we saw a really weird number, then we could try to fix that. Okay, so our loop is ready, I think. So let's try to run it. Okay, so it has run, and we can see that like when it runs, it doesn't spit anything out. We just know it's done because this little like prompty arrow has come back to say it's ready for the next thing. So if I wanted to do like 3 + 2, it would be ready for that. Okay, so it's ready. Now we can look at the histogram of the simulated test stats. And let's make this a little bit bigger so that it has some space to create our histogram. Okay, so there is our null distribution, or in other words, this is the set of test statistics, in this case, the set of differences in means, when we resample the data, assuming there's no difference between bio and sociology with the textbook prices. Okay, so we can see that we have 0 pretty close to the middle, and that makes sense because our null hypothesis, remember, was that the two means are different, are equal, and so there should be no difference in the test stats on average. And so that's why in the middle here we have 0, reflecting no difference in the two groups' prices. All right, so that's our null distribution. Now we want to go in and compare our original test stat against these simulated test stats. And let's remember what our OG test stat is. It's 140. So if we wanted to, we could add that line there. Let's make a vertical line. And I always forget the syntax, but let's see. Okay, yeah, V equals whatever. Let's just try this. Oops. Okay, there we go. So now we've added the line in red. And so now we can see here's our original test stat. So it is quite extreme compared to our simulated test stats, which we simulated again under the null hypothesis, which says that there's no difference between the two means. Okay, and just in case it's not obvious, I colored it red so that I could actually see it. Otherwise, it's like pretty easy to just like not know where it went. Okay, so intuitively, when we look at this plot down here, we can probably guess that we're going to end up rejecting the null hypothesis in favor of the alternative. In other words, we're going to have solid evidence to say there's no way that biology majors and sociology majors pay on average the same amount for textbooks in a semester. Looks like we have really solid evidence to say that biology majors pay more than sociology majors for textbooks on average during a semester. Okay, now let's count how many simulated test statistics are more extreme or as extreme as our OG test stat. So in other words, if we do sum and then we want to know how many OG how many of our null dist ones are greater than or equal to our original test stat, because we're wondering how many from this null distribution exceed 140, which was our original test stat. And so there were 298. So let's break this down a little bit. In the middle, we have this null dist greater than or equal to OG test stat. And so what this does is goes through and compares each entry in null dist against OG test stat and tells us true or false. So this is gonna spit out like way too much info, but we're just gonna do it anyway. If we do this and just run the middle bit, null dist greater than or equal to OG test stat, it goes through and tells us true or false, true, false. And so, for example, let's look at entry 9995. If we look at null dist 9995, or rather 995, we have $87.50 was the difference in means. Compare that against 140. So 87.5 greater than or equal to 140, and we get a false. So that's why we have false here. Now let's look at entry 960 and do the same thing. So in the 960th resample, we had a difference in means of $140. And is $140 greater than or equal to 140? Of course, we're going to get a true. And so that's why we have a true here in this entry 960. Okay, the way that R works is it treats true as 1 and 0 as false. So here we can see true is a 1, false is a 0. So if we take all of these and sum this whole thing up, it's just going to be counting how many times we have a simulated test stat greater than or equal to our original test stat of 140. So summing this all up, we see that we have 298 simulated test stats that are greater than or equal to our original test stat of 140. And a lot of them actually are 140 exactly. So we have most of what we need now to calculate our p-value. So let's split it up into two steps. The numerator is the sum of the number of, or the numerator is the number of simulated test stats that are greater than or equal to our original test stat. And then we add in 1. And the reason that we add in 1 is because we also want to count our original test stat. So numerator, number of test stats that are greater than or equal to our original test stat plus 1. And then our denominator is just m. So if we have numerator divided by denom, this is going to be our p-value, and our p-value is 0.00299. So just to make that really clear that this is our p-value, I'm going to label it p-value so that we can see p-value is 0.0299. So our p-value is pretty small, and that if we want to use a significance level of 0.05, we can see that our p-value is less than 0.05. And so then we can reject the null in favor of the alternative. In other words, the mean amount that bio majors spend on textbooks over a semester is significantly greater than the mean that amount that sociology majors spend on textbooks in a semester. Okay, so this is our conclusion. And remember, you always want to end with a conclusion that's in the context of the study. So do not ever just end with reject null in favor of alternative. You need to interpret it in the context of the study. So while this is a good little in-between step so that we can think about okay, how do we set up this interpretation? We cannot end here. We have to interpret our conclusion in the context of the study. In other words, someday when you go to your boss or you're writing this up in a paper, you don't want to just speak in reject null in favor of alternative. You want to make it understandable to your boss or to your coworkers or to the people reading your paper. Okay, so this is our permutation test. We did this just with a super small number of data points, but we could definitely add on a whole bunch more data points and it would work the same. So say we want to add on 400, 386, 298, some other numbers, and then some more sociology numbers. Then we could just go ahead and run this whole thing again. And we could find our p-value is 1e -4. So in other words, let's look at our numerator. Our numerator for our test statistic was just 1. In other words, the only time that we had, or rather, there were no simulated test statistics that were greater than or equal to our original test statistic. And so then this part was 0, this part was 1, yielding a numerator of 1. Then our denominator was 10 to the 4. So of course 1 divided by 10 to the 4 is 10 to the -4. So that's why we have gotten a p-value of 10 to the -4. All right, so that is it. And with these made up numbers that I just threw in there, we could still say the mean amount that bio majors spend on textbooks over a semester is significantly greater than the mean amount that sociology majors spend on textbooks in a semester. All right, good luck. Hope that helps. And remember, as you can kind of see while we worked our way through here, you want to put in a lot of comments, especially as a newer programmer. This will be really useful when you come back to work on things later, or if you're having a problem and you need to debug it and you need help, then having the comments will help you remember what's going on. Another tip to remember is if your code doesn't work, in particular, if your for loop doesn't work, you really need to dig in there and go through line by line to make sure that everything is working the way you think it should work. So even though this whole process is about randomness, we can go in and just keep the same random numbers for one iteration of this loop and just use these. Oh, I actually found a mistake. So when I increased the number of data points in the bio group, so now the length of the bio group is 9 and the length of the sociology group is 6. So now we have a sample size of 15, 9 in one group, 6 in the other group. So this actually should be sample 1 through length pooled dat, and we can check that that's the right thing. Yep, 15. And then size equals length bio. And let's just check that. 9. Perfect. So then when we run this, we'll get 9 numbers here, and we can just check that. We have 9 numbers, and then that means that pooled dat will go in and grab those 9 data points. And pooled dat negative these will go in and grab the remaining 6 data points. Okay, so let's run all that again. And we get a p-value of 6 times 10 to the negative 4. So that's our new p-value, still very small. We would end up rejecting the null in favor of the alternative, meaning that we can make the same conclusion that we had earlier. The mean amount that bio majors spend on textbooks over a semester is significantly greater than the mean amount that sociology majors spend on textbooks in a semester. All right, so that is our process. Go forth, conquer the permutation test. You got this. Good luck. And have fun. Take care.